Somewhere above your head right now, a machine the size of a school bus is hurtling through space at over 17,000 miles per hour. It has shown us the birth of stars, the death of galaxies, and the very edge of time itself. But it's falling. Silently. And eventually, it's going to come back down. This is the story of the Hubble Space Telescope. What it discovered, what it means, and what happens when gravity finally wins. Launched in April 1990, Hubble has been orbiting Earth for over 3 decades. It travels at roughly 17,500 miles per hour, fast enough to circle the entire planet once every 90 minutes. But speed isn't what makes Hubble special. What makes it extraordinary is where it sits. Most telescopes on the ground have to deal with Earth's atmosphere, a constantly moving, swirling layer of gas that blurs starlight and blocks entire ranges of radiation. Gases like ozone absorb ultraviolet light almost completely. Turbulent air is what makes stars twinkle, which sounds romantic until you realize it's a nightmare for precision astronomy. Hubble sits above all of that. From up there, it sees the universe with a clarity that was simply impossible before. The images it captures are so sharp that astronomers compare it to reading the date on a coin from a mile away. Before Hubble, scientists couldn't even agree on how old the universe was. Estimates ranged wildly. Now, thanks to decades of careful observation, we know the universe is approximately 13.8 billion years old, about 3 times older than our own planet. But that's just the beginning. Hubble confirmed that nearly every large galaxy in the universe has a super-massive black hole at its center. Not some of them, nearly all of them, including our own Milky Way. It discovered 2 previously unknown moons orbiting Pluto, Nix and Hydra, from over 3 billion miles away. It captured the first ever direct images of planets around other stars, and turned black holes from theoretical objects into things we could actually see. And perhaps most remarkably, Hubble gave us proof that the universe isn't just expanding, it's accelerating. The space between galaxies is stretching faster and faster over time, driven by a mysterious force scientists call dark energy. Nobody fully understands what dark energy is. We just know it exists because Hubble showed us it had to. One of its most stunning achievements was creating the first ever 3-dimensional map of dark matter, the invisible substance that makes up most of the universe's mass. The map revealed that dark matter isn't spread evenly. It forms a vast cosmic web of long filaments, and where those filaments intersect, galaxy clusters form. It was the first time humanity had ever directly observed the large-scale skeleton of the universe. Here's something that sounds like science fiction, but is completely real. Every time you look at a star, you're looking into the past. Light takes time to travel. The light entering Hubble's mirror left its source thousands, millions, sometimes billions of years ago. By the time it reaches us, the stars we're observing may have already changed beyond recognition, or ceased to exist entirely. Hubble has used this to our advantage. By pointing at the same tiny patch of sky for days at a time, it has captured galaxies so far away that their light has been traveling toward us since before our solar system even formed. The most famous of these images, the deep field photographs, show thousands of galaxies in a region of sky so small it would be covered by a grain of sand held at arm's length. Each one of those tiny smudges of light is an entire galaxy containing billions of stars. In a very real sense, Hubble is humanity's time machine, showing us not just the universe as it is, but the universe as it was billions of years before Earth existed. Now for the part nobody likes to talk about. Hubble orbits in what's called low Earth orbit, high enough to avoid most of the atmosphere, but not high enough to escape it completely. Earth's atmosphere actually extends much further than most people realize. And even at Hubble's altitude, there are enough stray particles to create drag, a slow, invisible braking force that pulls the telescope a little closer to Earth over time. In the past, astronauts aboard the Space Shuttle would visit Hubble, repair it, upgrade it, and use the shuttle's thrusters to nudge it into a slightly higher orbit, buying it a few more years. The last servicing mission was in 2009. The Space Shuttle program ended in 2011, and with it, any chance of another boost. Hubble's orbit has been decaying ever since. Scientists have studied the trajectory carefully. The best-case scenario puts Hubble in orbit until around 2040. The worst case, it could begin an uncontrolled descent as early as 2029. The most likely estimate right now is somewhere around 2033. And here's the issue. Hubble was never designed to re-enter Earth's atmosphere safely. It doesn't have a heat shield. It doesn't have a parachute. When it comes down, it will partially burn up, but not entirely. Debris could scatter along a path hundreds of miles long. Scientists have run the numbers. If Hubble re-enters along its current orbital path, the chance of debris causing a casualty is estimated at around 1 in 330. Way higher than NASA's safety standard of 1 in 10.